Hello everyone, this is Shubham. In this video, I'll be talking about the fundamentals of mathematics, which is required for any sort of competitive exam, right? So let's start now. So this lecture is about fundamentals of mathematics. All right. So we'll begin with the basics of maths, that is the numbers. So first section is we should know different types of numbers. First number is natural numbers. And what are natural numbers? That starts from 1, also called as counting numbers. So we can call it as 1, 2, 3, and so on and so forth till infinity, right? Then we have second set of numbers that is called as whole numbers. So when we add 0 to natural numbers, we get whole numbers, right? So we have 1, 2, 3, and then again till infinity, right? So this is whole numbers. Then the third set of numbers is integers, which is nothing but positive and negative whole numbers, we can say 1, 2, and then till infinity. And here also we have negative 2 and so on and so forth till negative infinity. All right. So here now the thing is, we should also know about what are positive numbers and what are non-negative numbers. So non-negative means something which is not negative, right? So non-negative means 0, 1, 2, 3, and so on till infinity. All right. Wherein when we say positive numbers, that means starts from 1, 2, 3, until infinity. All right. So this is the fundamental difference between non-negative numbers and positive numbers. All right. So I hope this much is clear to you. Next, once we know about natural numbers, whole numbers, and integers, then we dealt with all the sorts of arithmetic involving natural numbers, whole numbers, and integers, right? Like for example, plus, minus. Okay. Then we got next set of numbers, that is rational numbers. All right. So rational numbers. So if you have paid your attention to this word rational, right? So there is something hiding over here. That is the word ratio. Okay. So what it is nothing but the ratio of two numbers, p over q, such that q is not equals to 0 and p and q both belongs to integers. All right. So ratio of any two numbers is nothing but rational numbers and usually denoted by capital Q. Then next set of numbers is irrational numbers. And what are irrational numbers? Irrational numbers are nothing but something which is not rational. So can we denote it by q dash? Yes, we can, right? So something which cannot be written in the form p over q, right? Or we can say any fraction, right? P over q says that it's decimal expansion. Right? This is another definition of rational numbers or irrational number. Decimal expansion is such that it is non-terminating and non-repeating, right? NT&R stands for non-terminating and non-repeating. Wherein for rational numbers, sometimes it could be non-terminating but repeating, or it is just terminating. All right. So we can take few examples. Let's say, for example, we have 2 over 3. This is nothing but 0.666 and so on and so forth, right? So here it is non-terminating but repeating. 6 is repeating itself. So it's a rational number. All right, so it's a rational number. But if we take 3 over 2, so this is terminating 1.5, isn't it? So this is also a rational number. So now let's discuss what are the few examples of irrational numbers. So irrational numbers, few examples of irrational numbers would be, let's say, for example, pi. All right. So its approximate value is nothing but 3.14, right? So similarly, pi by 2. This is also important. Approximate value we should know is 1.57, right? All these things should be in your tips. So pi is 3.14, pi to 2 decimal place, and pi over 2 is 1.57. Right? Similarly, there is another irrational number that is called as e, that is Napier constant, whose approximate value is 2.718. Right? And you should also know that e is nothing but a series called as 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus so on and so forth. All right? So the approximate value of e is nothing but 2.718. Okay, all these are useful things. Then dealing with numbers, irrational numbers in terms of square roots. So square root of any non-square number, root 2, root 3, right? Root 5, root 7, isn't it? All these are irrational numbers, and these are denoted by q dash. Okay. All right. So here, as you can see, this 2, 3, 5, 7. All these are prime numbers, basically, right? So let's quickly discuss what are prime numbers. So next set of important numbers are nothing but prime numbers. Okay. So what are prime numbers? Prime numbers are nothing but which have only two factors, right? They have only two factors. And what are those? 1 and itself, isn't it? So this is prime numbers. So prime numbers, why they're important? Prime numbers are important because any number which we take can be written in a unique way as a product of prime numbers. So that property is basically called as fundamental theorem of arithmetic, right? So what it says basically, any number you take, it can be written as a product of prime in a unique way. Let's say, for example, if I take 21, so it is 3 into 7, right? So 3 and 7 both are prime numbers. Similarly, if you take 20, the 20 can be written as 4 into 5, and 4 can be written as 2 into 2, which is 4 into 5, right? So this is called as fundamental theorem of arithmetic. So these are prime numbers. Next set of numbers, something which is not prime, is called as composite numbers. So let us quickly discuss what is composite numbers. So next set of numbers we have is composite numbers. So what are composite numbers? Something that has more than two factors, right? Any number that has more than two factors. All right. Any number which has more than two factors is called as a composite number. All right. So for example, it could be 72. All right. So this can be written as 2 into 36. Similarly, one more such example could be 9, which is 3 into 3. Basically, any number which has more than two factors is composite. Now, mind it, one is neither composite nor prime number. Okay. Yeah. Next, very, very important note. Q dash. This is just remember this as a fact. Q is a rational number. Q dash is a irrational number. They both occur alternate to each other. Okay. And still the research is going on. Mathematicians have been working since 15th century to 16th century. And just the only thing that they know about this is they occur alternate to each other. Right. So that is the reason pi and 22 by 7. Right. This is the very next number, and it is not certain when it will appear. Right. But this is show that this rational numbers and irrational numbers, they are alternate to each other. That means if you have one rational number and the next rational number, so there will be a irrational number between them. Okay. So this is important. So that is the reason pi is approximated as 22 over 7. Okay. So let's discuss the different set of numbers. Next set of numbers is called as twin prime. Twin prime numbers. So what are twin prime numbers? So the prime numbers which have only 2 as a difference. Okay. So for example, 3 and 5. The difference is 2. Then we have 5 and 7. Right. So the difference is again 2. 17 and 19. So again the difference is 2. Similarly, you can have taken 11 and 13. Right. So basically two prime numbers whose difference is 2. It's called as twin prime numbers. Then after twin prime, we have another set of prime numbers classified as co-prime numbers. Next set of numbers is co-prime numbers. So what are co-prime numbers? So in co-prime numbers, the numbers are not necessarily of prime nature. Okay. So it could be any natural number. So the definition is any natural number, all right, which has HCF as 1. The only common factor is 1. Okay? So any two natural numbers having 1 as HCF, that is the highest common factor. So for example, 13 and 14. Right. So what is common between them? Only 1. Right. So sometimes co-primes are also called as relative prime numbers. This is very, very important. Relative prime numbers. All right. Yeah. So now let's discuss quick facts about these numbers. So which is the smallest prime number? Smallest prime number is nothing but 2, and it is the only even prime number, isn't it? Even. This is the only even prime number. All right. So next thing could be, what is the smallest composite number? Give it a try. So smallest composite number is nothing but, so composite number means what? Which has more than two factors. So that is 4. All right. So we have discussed about numbers. Now let's discuss about the arithmetic of rational and irrational numbers. So let's discuss this. The next one is the sum, difference, the product, and the question of any rational number, right? We're talking about of any rational number is always a rational number. All right, this is very, very important. Let's discuss few examples. Let's say we have a number called as 2 plus 3. Both are rational numbers, isn't it? So if I have, we get 5, and 5 can be written as pi over 1. Similarly, 2 into 3. is 6 rational number, and then 6 divided by 2, which is nothing but 3, right? All these are rational numbers. So all the arithmetic operators, right, plus, minus, multiplication, division of any rational number will always give us a rational. But when we talk about irrational numbers, so we can write in case of irrational numbers, all right, plus, minus, product, or quotient, right, of two irrational numbers may be rational or irrational, right? Both the possibilities are there. So let's take your example. Let's take 2 plus root 3, right? So 2 is a rational number, but root 3 is an irrational number, all right? So root 3 is 1.732, so this will be 3.732, and it keeps on going, isn't it? So this is basically what kind of decimal expansion? Non-terminating and non-repeating. So it's irrational, isn't it? But let's say if you have 2 plus root 3 and multiplied by 2 minus root 3. So this is a plus b minus b, which is a square minus b square, isn't it? So this gives us 4 minus 3, which is equals to 1, and this is now rational. All right, that is the reason. In case of irrational numbers, addition, sum, difference, product, quotient of any two irrational numbers may be rational or may be irrational. All right. Next important concept what we should know is HCF and LCM, which is very, very important. Okay, so now let's discuss about HCF, which stands for highest common factor, and LCM. All right. Yeah. So let's say if I talk about find the HCF of 2, 4, and 8. Right. So what is HCF? What is the highest common factor that divides all these three numbers? So it is 2. Right. Similarly, if I talk about LCM of 2, 4, and 8. Right. So what is the least number which is divisible by all these three numbers? So that is nothing but 8, isn't it? Now, important thing to note over here is HCF is less than LCM. Okay, this is very, very important. Now let us talk about LCM and HCF of like nature numbers. What do I mean by this is, for example, we are given with find the LCM of a number 3 and irrational number 5. Okay, so you would be thinking nothing is common between them. So the answer is 3 pi. No, so the answer for this is not possible. Okay, now the reason is this number 3 is a rational number and pi is irrational number. All right. So basically, let's say if you take the product as 3 into pi, 3 pi. So if I divide the LCM by individual numbers, so 3 pi divided by 3, which gives you irrational, right? But what is the actual concept of LCM? When we divide the LCM of these two numbers by these numbers, right, individual numbers, the answer should be integer. All right. So what we see over here is when we divide the LCM by the numbers, right, individual numbers, we get irrational number, right? So that is the reason it is not possible. One more such example could be, let's say if I ask you LCM of 3 pi and pi square. Okay. So this is also not possible. Why it is not possible? See these two numbers. 3 pi is irrational and this is pi square. All right. The nature of both these numbers are different. Here it was rational and here it was irrational. Here it is irrational pi square and this is 3 pi. All right. So if you say that the LCM of 3 pi and pi square is 3 pi square, so now if this is the LCM and if I divide it by individual numbers, let's say if I divide by 3 pi, so what I get pi? But what I should get an integer. That is what the definition of LCM is. Okay. So but pi is not an integer. It is not an integer, isn't it? Therefore, the LCM of these two numbers is not possible. But let's consider this thing. LCM of 3 pi and pi. So this is 3 pi. Okay, because these two numbers, 3 pi and pi, both belongs to the same category. What do I mean by this is, now you can check for this one, right? So 3 pi, if this is the LCM, 3 pi divided by 3 pi gives you 1. So 1 is an integer. All right, perfectly satisfied the condition for LCM method. Now 3 pi, if we consider the LCM as 3 pi, and if I divide 3 pi by pi, right, pi and pi cancels out, we get 3. So 3 is again an integer. All right, so therefore, the LCM of 3 pi and pi is 3 pi. So you have to be very careful with the numbers what is given to you. Make sure that both the numbers belong to the same category. All right. Then again, based on LCM, we have LCM of fractions. Let's discuss that as well. Let's say, for example, we are given with find the LCM of a over b, then we have c over d, and then we have e over f. Right. So how do we find this? So we take the LCM of all the numerators separately, a, c, and e, divided by HCF of the denominators b, d, and f separately. Okay. So what is the LCM of a over b, c over d, e over f? It is LCM of the numerator divided by HCF of the denominator. So let's quickly take one question. Question says find the LCM of pi over 3, 3 pi over 4. All right. So first thing is to see whether these two numbers belong to the same category or not. So pi and 3 pi, so they do belong to the same category. Now what is the theorem here? The answer is LCM of numerator. So I have to write LCM of numerator, that is pi and 3 pi, over HCF of denominator, that is 3 and 4. Right. So what is the LCM of pi and 3 pi? Isn't it 3 pi? And what is common between 3 and 4? HCF of 3 and 4 is 1. So what is the answer? 3 pi. All right. So this is the answer. Now let's understand what are the important fundamental theorems about HCF and LCM. So fundamental theorem of HCF and LCM says the product of HCF and LCM is equals to product of the two numbers. Product of the two numbers. This is only valid for two given sets of numbers, right? And as we have already seen, HCF is always less than or equal to LCM of any two numbers. Okay, so this is what we have done. Now let me quickly ask you one question based on this. The question says, find the product of two numbers if their LCM is 5 and HCF is 25. So pause this video and do try it. Well, the answer over here is not possible. And guess what is the reason? What is the LCM given to us? 5. And what is the HCF? 25. So we know the fact that HCF is always less than LCM. Therefore, this is not possible. Okay, so be careful with this. So next concepts I'll be explaining in the next video. Thanks for watching.